All right, so this is Geometry Notes 8.5, talking about translations. So far we've talked about rotations, reflections, and now we're talking about how to slide or glide. A translation is also an isometry. We talked about this in the first day. The three isometric transformations are translation, rotation, and reflection. So if on a test question they ask you which is true, a translation is not a reflection, it's not a rotation. We don't even know what a transcription is. It's an isometry. So please don't forget that translation preserves distance and angle. Basically, it looks like this. It's a slide. I'm taking a shape and I just slide it into place. It should land right on top of the A prime, B prime, C prime. So if we look at the coordinates of A, B, and C, you can plot those yourself, or you can just look at the notes that I've written up here. To get from A to B, we simply have to count. I went down 4, left 3, looks like, to get from A to A prime. So if we look at this as one set of points and a new set of points, all you have to think about is how did I get from there to there? We do that by adding or subtracting some number to both the x and the y. In this case, we added 3, or we subtracted 3 from the x value. -1 minus 3 got us to -4, and we subtracted 4 from the y value. So this right here is our transformation rule. And so, awesome. We subtract 3 from the x value and 4 from the y value. And there's our transformation rule, is what we talk about right here, our translation rule. And then here we have the original points and the new points. So I can either give it to you in pictures, like triangle ABC and triangle A prime, B prime, C prime, or I can give it to you as a rule and then make you draw the pictures. All right, so we talk about pre-image and image. Pre-image is before you move it. It has no prime values. The image is after we move it. It has A prime, B prime, C prime on it. This is what we call the coordinate rule for translation. This one I don't really use very often. I just kind of count down. Okay, down 4, left 3. Down 4, left 3. So, no time for questions. Moving on. If I were to give the problem to you in this scenario, I'd give you the rule, and I'd give you some point or some list of points. Okay, notice how it says the image. What is the image of P? Okay, sometimes I'm going to give it to you where I ask you for the pre-image. We'll talk about that in a second, but notice it's saying what is the image of P? Well, we plug in our value. This is our coordinate rule. We substitute in our information, right? So I know the point is 5, -3, and then we plug that in where it goes. And then we do the subtraction or the addition. Okay? So this is kind of the process we go by. I know my x and y. I know the rule. So this is saying I go down 8. Well, 5 minus 8 is -3. And then y is -3 plus 4 gives me 1. So I like this way of doing things because it's very structured. There's no way to get it wrong. If you want to try and just count, that's fine. That should help you with problems 1 and 2. Now notice here I've given you, I'm asking for the pre-image. That means that whatever we've got, whatever I give you, this Q has already been moved. Now I'm trying to work it backwards to find my original position. Okay? So if that's the case, here's my translation rule. Again, I give the coordinate rule. I notice that the image is added. Here's my 11 and 4. I need to work backwards to find out what x is. Okay? I need to find out what my original x and y were. So I do that by, I'm going to just emphasize the x value. Okay? Notice how x minus 8 got us to 11. So I've got to find out what the original amount was by adding 8 to both sides. And then I do the same thing for the y. Notice how I write the equation to find the y coordinate. Y plus 4 got me to 4. Well, what was y originally in order to get me to that point? And I say they're equal to each other, so I subtract 4 to both sides, and I find out y is 0. Okay, so to sum everything up, I started with here, with 11.4. Since it said pre-image, I know that the Q4 has to be the image, or the point Q, 11.4, has to be the image. So I plug that in where the image goes. And then I had to work backwards to find out where I originally started from. Hopefully that helps. Okay. I'm going to help you with questions 3 and 4. Now if we look more in the picture, okay, I've got A prime, B prime, C prime is the image of ABC after the translation. Now we got to write the coordinate rule. To write the coordinate rule, all we have to do is how did I get from C to C prime, or A to A prime, or B to B prime? It wouldn't matter either one. So we pick a vertex, any vertex, with A because it's on the outside. How far to the left did I move from A? I went 1, 2, 3, 4, 5, 6. So I would put in -6. And then how far up? 1, 2, 3, 4, 5 looks like. I would put y plus 5. And there's my coordinate rule. I'm done. That's it. If I ask you to write me a coordinate rule, you've just got to count how far left, how far up. That's translations. Now if I say, same concept. I have A prime, B prime, C prime. I have ABC. I pick any vertex I want. And I decide how far did I move. I moved right 3 at the +3. I moved down 5 at the -5. There's my coordinate rule. This is as easy as 1, 2, 3. I mean, you just count 1, 2, 3, 1, 2, 3, 4, 5, and you put in your information. Okay. Same process here on 8.20. Pick any vertex. A looks like the easiest one. How far in the x direction? Looks like we're moving -6, and then we're moving -4. So my coordinate rule is for every xy, we move -6, -4. Now look at B. Same concept. I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Notice how the movements for A and the movements for B were the exact same. That's what requires it to stay as an isometry. Every point has to move the same distance in the y direction and in the x direction. So, describe in your own words what a translation is. Feel free to pause the video now to take a moment to work on that. All right, so now we're going to talk vectors. Vectors are awesome. A vector is another way to describe a translation. They are given by a direction and a magnitude or size, okay? It's hard to kind of explain without showing with pictures and stuff, so we'll get there. A vector is represented in the coordinate plane by an arrow or a ray, okay? So a line segment is just a distance, okay? But a vector is like a line segment, but it has to be in a specific direction and it has to be a specific size, okay? This is a good example of what a vector would be. It starts at B and goes towards A. That's why it has to have a direction. It's going this direction. And notice the symbol above, the A with a little arrow above it, the BA. That means I started at B and I went to A. That's it. This is called vector BA. Okay, the initial point is B, and it goes to the terminal point, which is A. So for as far as vocabulary words go, B is the initial point, A is the terminal point, meaning I start at B and I go to A. All right, vectors are always named in one of two ways, sometimes with a ray, such as this, like ray BA, or it can be written as a lowercase letter. So like U, this would be vector U. I'll probably use both, so be prepared for any of them. So either you'll see BA as a ray or U as a vector. And you'll always have definitions for what the vector means based on what we call it. So they're used to indicate that a translation has taken place in our geometry class. Okay. In the real world, vectors are used to show force and do some pretty awesome calculations. If you ever take a statics class in engineering, you'll deal with vectors all the time, dealing with shear forces and finding out when the bridge will collapse and things like that. But for us, we're just talking about it means a translation has happened. Each vector will have a horizontal component and a vertical component, okay? And it's written with these funky little parentheses. this is one way to write a vector, indicating that there's a vertical component and a horizontal component to each vector. So every vector can be written as the vector u, but that vector can be broken down into how far right and how far up it went. So this would be the component form of the vector u. And there's lots of different ways to write vectors. You can use angles, you can use all sorts of different things. But as far as the component form goes, which is what we're going to be using, this is the x direction and this is the y direction of the vector u. Okay, so now if I translate e at this point, 5, 4, using the vector 6, negative 7. All right, well, this is the same thing as doing a translation rule. Here I am at 5, but the vector says I've been pushed to this right 6. So I add 6 to 5. And it says I got pushed down 7. So I go down 7, and there's my new point. Here's the new vector, or here's the new point based on this vector v. Okay. So instead of writing a coordinate rule, x comma y, arrow over x plus k comma y plus h, I can write just a vector notation and have you move it in the same direction. So here I am at 5, 4. I'm using this vector negative 5, 4, which means it's negative 5 in the x direction and 0 in the y direction. I notice that it's moving 5 to the left. That puts me at 0, and 0 in the y direction, which leaves me at 0, 4. All right, so now we're going to name the vector and write its component form. So the vector, I start at B and go to A. So my vector's name would be BA. My initial point is B, my terminal point is A, so don't forget the little arrow above. This little arrow indicates that it's a vector or array. Now my component form, I move right 5, 1, 2, 3, 4, 5, so it's a positive 5. I move down 1, 2, 3, 4, that puts me at a negative 4. And that's my component form. So again, same process, name the vector and write the component form. I start at C and I go to D, so it's ray CD. My x direction is a negative 1 going left 1. My y direction is a negative 5 going down 5. That is the vector and its component form. You'll see these on the test. So same, name the vector. Starts at F, goes to E. So it's vector VFE, and the component form is negative 5, 0. I went left 5, up and down 0. So I call it negative 5, 0. Okay. Starting at G, going to H. Ray GH. Components, I'm not going left to right at all. So it's a 0. I go up 5, and there's my vector component form. All right, same process. Starts at Q, goes to P. That means it's ray or vector QP. My components are positive 5 and positive 6. So this will help you with problems 9 through 11. All right, so there's 3 methods for translation. Visually, you can count the translation out by using a pen or a pencil, just counting 1, 2, 3, 4, 5. Or you can, this is the description of visual. If it translates to the left, you just count to the left, count 3 units down, and there's my new point. If you wanted to add a translation matrix to the pre-image matrix, you would have to add it. You can look at the basic concepts if this interests you. Basically, you take your shape, your A prime, B prime, C prime, and you add or subtract based on what you're trying to work on. And then also you have the coordinate rule option, which is what we first showed, which was the x comma y arrow over to the x plus h and the y plus k type of a scenario. All of which are good ways of going about it. Okay, so your coordinate rule is if it's to the right, it's plus h plus k, or if it's both, it's plus h and plus k. This is really the only rule you need because this just means that h is 0. Notice how this one here, a plus h, well, if the h is a 0, it means it's not going right or left at all. So that's kind of what it means by up or down. Anyways, some thoughts for you. Okay. The 3 methods for translations, you get to choose your favorite method on the test. Be sure you're familiar with how to do them, obviously, by doing your homework, hint, hint. Okay, so graph the polygon represented by the matrix. This is going to help you on the test, okay? This is for test hint purposes. This is how you're going to see it on the test. First point, graph the polygon. You should be able to accomplish this. Plot the points. Connect your dots. Oh, there's an oop. On your sheet, just use the green border line to count up to 6. So you count all the way over to 6. And then you connect the dots. There we go. All right, you should be able to plot the points for the matrix, for the graph. If you don't do this basic concept, then on the retest, I'm not going to let you get any points at all. You have to graph at least the point that I give you. Now, based on the matrix, or the vector, now you have to shift this shape according to what I told you in the vector right here. Now we go left 1, down up 3, left 1, up 3, left 1, up 3, just using my fingers, and then I got my new points. So now we connect the dots, and then we have to use, oh, this is going to show you, this is one way to do it, my apologies. I would want you to label it as A prime, B prime, and C prime. But if you wanted to use the matrix method, I give you the original coordinates, and now you got to find the new coordinates. And we would do this by simply subtracting 1 from each, right? Here's the x coordinate. Just subtract 1 from each, and then add 3 to each. So this is what we meant by using the matrix addition or subtraction. We can just add straight through. And those are our coordinates. We label them A prime, B prime, C prime, and we're done. Okay, so on the test, you're going to have 1 point for graphing ABC. You're going to have 1 point for doing the translation correctly, and then you're going to have 1 point for labeling and graphing the image correctly. So let's get an example of what we're talking about here. Use the described translation and the graph of the image to find the matrix that represents the pre-image. All right, now, this means that I've got P prime, Q prime, R prime, S prime. I don't want those. I want the original. So if I had moved them 4 units left and 1 unit up, all right, I got to work out to where we began from. So 4 units left. Well, that means I got to move the opposite of that. So we use 4 units right and 1 unit down. So this is the translation rule we have. To work backwards, I've got to do exactly that. Work backwards and go 4 units right and 1 unit down. All right, so we do that for each one of the points. And there's our original matrix. So if I told you to move left, you have to work it backwards by moving right. Hopefully that's sinking in. Feel free to rewind and re-listen to it if you liked. All right, so no time for questions. Summarize what you learned in the lesson. Make sure you fill these out. These are free points. As far as calendar goes, psychedelicness, awesome. We just covered translations tomorrow as dilations, and then composition, and then we have tests. All right, so some tips, okay? These examples will help you with these homework problems. Help with 20 to 22, okay. For these 2 homework problems, the image of point P is P prime. Write the component form of the vector used to describe the translation. So the x-coordinates from -3 to 5. From -3 to 5, we went 8. And then from 6 to 2, we went -4. So our vector is 8, 4. 8, -4, my apologies. All right, remember the translation is an isometry. All lengths and angles are preserved. If your picture doesn't look the same, then we've got problems. Also notice that if I tell you it's a translation, then look, S and darn well better equal 8. They have to be the same length and the same angle. So 10 and 2t, that means t has to be 5 because they have to equal 10. 162 equals 3w, then w's got to equal whatever 162 divided by 3 is. R has to equal 100. The angles have to be the same. Okay, don't forget that's what it means to be isometric. It means that each piece is equal to each corresponding piece. There you go. Hopefully this helps with your homework.